Assalamu alaikum. My name is Hossein Ahmed. Currently pursuing Bachelor of Sciences in Chemical Engineering from Dhaka University of Engineering and Technology, Gazipur. I'd like to talk to you today about the most important, most prominent analytical technique, high performance liquid chromatography, HPLC. Uh, let's move and discuss. I'll be briefly discussing these contents throughout the presentation. It is applicable for only liquid phase system. This analytical technique that involve high pressure flow of liquid to separate, quantify, identify the substances in a mixture, where it gives a chromatogram, and it is employed in HPLC chromatograph instrument. It has a wide application and it is versatile. This analytical technique used in many sectors where precise separation and quantification are required, like pharmaceuticals, to assess drug purity, quality control, analyzing blood, plasma in biomedical engineering, uh, analyzing the fuel samples content raw materials in chemical and petrochemical sectors, and food contaminants, vitamins and uh, toxins are measured in food and beverage industries, and water purification, environmental management and monitoring, and clinical diagnostics and forensic sciences. The working mechanism of the HPLC has the following strategies, like sample preparation, sample injection, mobile phase delivery, column separation, detection, and data analysis. It has some components to employ the HPLC system. So this process begins with the injection of a small amount of liquid sample to the column as the stationary phase. A high pressure pump then moves the liquid phase, I mean sample, to the column, and due to varying interaction and chemical structure, samples are separated. Separated components go through the detector, uh, where mostly UV visible detector has been used. Other can be. So each components absorb the light, and detector measure the absorbance, which is directly related to the concentration. Uh, Detector then sends signal to the computer, and it gives a chromatogram where a graph absorbance versus retention time. Retention time tells about the components, and peak area or height, like this. These are the peak area and height. It identifies, tells the how much amount of substance is present in the mixture. This is a typical chromatogram of various components, and the separation process is depicted here. Separation is accomplished by different moving speed of each component. So it has huge advantages. It has high resolution and good separation compared to any other system. It gives a rapid and reproducible analysis, which helps in research, chemical composition, and it has a high resolution, good separation. It has a high sensitivity to detect small or traces labeled amount substances. So it is easy to use, and it gives a better product purity, and to assess the quality control. It is versatile, and it has despite the advantages, it can be costly to produce organic solvent, and it has some complexity. uh, it can be low sensitivity for certain compounds, and it cannot apply for gas or volatile system substances. Volatile substances are suitable for only gas chromatography. To understand the HPLC system and how does it work, a recent research article has been used where directly HPLC systems is used. So the article has been found in ResearchGate, and the title is Chemical Analysis of Polyphenolic Content and Antioxidant Screening of 17 African Propolis samples using RPHPLC and spectroscopy. So in this research, they are using a reverse phase system where solid is non-polar solid. The solid adsorbent used in column inside the column, or stationary phase, uh, where the separation, molecular separation is obtained, and this research belong to the five others, like you can see here: Shankar, Kai, and the sample is resinous complex composition, produced from honeybees and found in many different regions in Africa. And the main objective of this study is to uh, quantify the 13 compounds in the sample, resinous sample, uh, propolis. Right? So the sample, they are they are using 17 African raw propolis. Uh, the sample preparation method is involve extraction, filtration, sonication, and further filtration to inject the sample into the system, and and already standard solution has been prepared to generate a calibration curve. This measured properties is flavonoid and phenolic acid content, uh, where 13 marker compounds analyzed, like some acid in the sample, uh, caffeic acid, garlic acid, and other components. So the Nigerian samples especially had the highest flavonoid content and phenolic content, and this has been successfully quantified 13 phenolic flavonoid markers like quercetin, naringin, caffeic acid, and others. These are the results from the research graph of absorbance intensity versus retention time, and the samples collected from four different regions, uh, which is Malawi, Tanzania, and Zambia, and Nigeria. So the RP-HPLC study shows that propolis from Malawi, uh, Tanzania, and Zambia contain a greater uh, and figure 4 chromatographs of Nigerian raw samples, where um, 9 components are identified, and the chromatograms for Zambian propolis sample, where uh, 6 marker compounds have been observed. So we have they use uh, maximum samples in Nigerian. So, but the compounds, matter compounds has lower proportion. So these are the references for my presentation and research article. Why we choose this system? Because this system works with the liquid system, and in especially in industries and other institute, uh, we have been used uh, continuously this liquid system, liquid phase system, and it gives reproducible analysis and rapid analysis and reliable speed and efficiency. Uh, so due to various specification and facilities, we go for HPLC system. It is definitely useful in maximum area of analysis.